Now we will solve sum of two values of CSES problem set. So it's a very famous problem commonly known as two sum problem. So let's jump to the problem statement. You are given an array of n integers and your task is to find two values whose sum is x. Okay, that's like in we have given an array, and in that array we have to find two element whose sum is x. Okay, so we have two integers n and x, so the size of array and the sum target sum, and we have array as an input. Okay, print what's the output. Print two integers, the position of the values. Okay, cool. If there are several solutions, you may print any of them. Like if we find one solution, we can directly print it. Else, we can print impossible. Okay, so let's think what we can do here. Let me take this test case only. Okay, so here our target is 8 in this array. Okay, so suppose what can we directly think? We can like traverse the array like we can for 2 we can check if 8 minus 2 6 is present or not. For 2 we can traverse from from 1 to 3, 1 from like this. We will check 7. If it is equal to 6, then we will check 5, and then we will check 1. No, so we will move to 7 now. For 7 we will check if 8 minus 7 1 is present or not. So we will check first 5, then 1. Yeah, we got it. 7 1. So we will print it. So you might think that's a simple, but sometimes we may get a doubt. For 7 I am checking from here. Okay, like I am not going backwards, I am going just forward. Suppose again there is a very big array, you could say. Okay, so suppose for this, what I can say, mm, yeah, for this 6 I will check this 9 only. For this 6 I will check if 8 minus 6 2 is present or not. Okay, so I will check here only, but we didn't get any 2, but here at backside we have 2's. Okay, so will that be a problem? No, it won't be a problem, because if we are checking for 6 and we intend to find 2, so before that, before checking, before applying operation for 6, we would have already checked for 2 here, and for this 2 the 6 would have come already. So we are checking one just once, so we have already checked this. That's why we are not going backwards. Okay, so let me tell you one thing. Like for this thing, suppose for 2, the answer lies in future elements. Okay, for 7, answer lies in future elements. For every element, the answer lies in future element. Okay, first of all, answer lies in future element. Okay, also, if a answer lies in future element, so that does mean, what does that mean? The current element might be the answer of past element. Yeah, answer for past element. Is it na? Like suppose for this 5, suppose say for this 1, answer might be in future element. Okay. But also 1 would be like 1 might be the answer also for the past element. Okay. So there are two things. Answer lies in the future element and the for current element. Here, let me write here again for current element. Answer lies in the future element, and current element might be the answer for the past element. Okay, that is clear. Okay, so cool. So now what I can do, like if I am at any particular index, suppose this. Okay, first I will check if is this the answer for any past element. Okay, first what I will do, if current element, suppose v of I, if I am at ith index, then I will check if I is the answer for past element. And also if I will check, then afterwards what will I do? Right now for vi, for v of I, answer lies in future element. Future future element. Okay. So if vi is the answer for past element, for vi answer lies in the future element. So what I can do, I can just move on or like store in any data structure. It can be the vector, if anything. We will see which is good. Okay. So let me write this code till here only right now. So we have an x input and array. So cool. C n C in x. Okay. And here let me change this. Cd. Okay. So I have taken the input. Now let's, for int I equals 0, I is less than n plus I. So what I can do, what I have to do, first I have to check if vi is the answer for past element. How can we check? What is the current number? Current, let me write in short. Int current number equals to v of I. Okay, is that good? Yeah, which is the current element. So its answer might be in the past. It might be in the past. Okay, it, sorry, the and like current element might be the answer of any some past element. So how can we check that? How can it be the answer of past element? If v x minus v of I, or I would say current element, is present in past. So okay, so that means in our current element is the answer of this past element, which is x minus current. Okay, so we have to check that. So how can we check current number very fast? Okay, if I have array and I have to find x minus c current till from 0 to I, so it will be O of n. Okay, so that's not efficient solution. But if I use like map or set or like these data structure, so it would be much faster. It might finding element would be log n or 1. Okay, so it would be much better. So that's why I have also, so if suppose I have find the current element also what I have to see the current element might the answer for current element might be in the future element. Okay, there are two things. Is current element is the answer of some past element, and in the answer for current element is present in the future element. Okay, you have to see left and right of the element. Okay, so for checking if I have to store the numbers in I would say map or set, and how to decide whether to use map or set. So see in the question, we have to print the positions of the values. So we don't need just numbers, we also need its position also. So we need two values at a time. So it's easy for us to use map because we can store in the form of key value pair. We can store the element value of the element as well as the index of the element. Okay, so let me map into comma into mp. Okay, if mp dot find x minus curr is not equals to mp dot end, that means I have found the element x minus c current. Okay, so what I can do, see out current, and also mm, what mp of x minus current, and sorry, here I have to print, we have to print the positions. So it's I and mp of current. Okay, so cool. Yeah, so we have done like, if the first part is done. Okay, if vi is the answer of past element, if we get the past element, we will just break out of this loop. And because we just need to print one answer. Okay, and also what I have to do, uh, I have to store it like this for this one. If vi For vi answer lies in the future element, so for future element, so we have to store it in mp of current equals I. Okay, so that's it. And also, if we have to print impossible, okay, for that we can done like we can use the indicator variable to check if like indicator Indicator equals 0. Okay. And if we find indicator, if we find any element, if answer is got, so we will change this to 1. We have green signal that the answer is found. Okay. If the answer is found, so if indicator equals 0, what does a red flag? Red flag means if it is red, so what I can do, we didn't find any answer, so what we have to print? Impossible. So is it? Yeah. So let me go with the test cases. There might be compilation error. No. So we have got 3 1. Okay. Okay. So 3 1. So do we need to print in sorted also? Actually, the indexes are like one based. So that's the problem here. And I don't think we have to print in sorted order. Let me, like, first of all, let me check here with -1 -1. Sorry, 2 plus 1 plus 1, 2 4. Where is I plus 1? There was nothing mentioned about the sorting of the answer, so let me check it. Yeah, so there was nothing such issue. Okay, so what we have learned. So first of all, the main thing we have first of all used the map data structure. So why did we use map data structure? That's the main thing, because we thought that storing elements and accessing the elements in vector would be much more costlier. Okay. And also, we why didn't we use set? Because we also need the index of a element, not just the element itself. So that's why we preferred map. Okay. So why didn't we use unordered map? We didn't use unordered map because I have said in my previous video that CSES and this code forces problem setters set like some test cases which give the like collision, like has collision cases. So in that, the instead of log n, the time complexity becomes n for unordered map. So map is better in CSS and code forces. Okay, so that's why I didn't use unordered map. And what I can say is, so we have, this is the like base of the idea, like base idea. Okay, so this will be used in some other cases also. So keep in mind for this. Okay, so this like it's kind of beautiful. Like if we are at a particular index, so what does that mean? It can be the answer. Its answer is present in future element. Okay, its answer is present in future element. Also, if every other element's answer is present in future element, so this might be the future element also. So that means it might be the answer of past element. So we have both future and the past. So that's very fun to imagine as well. So, and what we can say is, why did we decoded why we use map data structure. So that's it from my side. Like, I don't want to elongate more. Thank you.